In this video, we'll set up the gun behavior and ability to target enemies Doom style. We'll take into consideration Doom's aim assist, be able to shoot enemies above or below the player, and check for line of sight. In the process, we'll set up a super basic enemy system with enemy health. Before we get into the gun stuff, I was referencing Doom's gun mechanics and I noticed that the OG Doom has momentum for his player. He doesn't come to an abrupt stop like our player does, so we'll address that first. Okay, first off, let's clean this project window. I can't stress how important it is to keep this thing clean. So I'm just going to move my scripts where they need to go. I'm going to create a new folder for animation things. One's going to be a animators folder and one's going to be an animation clips folder. Now let's go straight into our player move script. So this block of code is where we get our starting input. It's either -1, 0, or 1. And then we put it all together and we finally use that to move our player. If we're holding the keys, we want this to happen. When we release the keys, we want something else to happen. We'll just say that here for now, and it's that we want the last number used as input vector to be lerped down towards 0. There's a function called move towards, which is probably better for this since a lerp never truly makes it to 0, but for us it's good enough. So let's lerp our input vector, and we're gonna lerp it towards vector3.0, and the time variable will be time.delta time, but multiplied by something that we control, so we'll call this momentum damping. And at the top we'll just say it's a new float and we'll set it equal to 5. And while we're here, let's go ahead and slow down our player a bit and we'll change this to 10. So back down in input, we're going to say this part is if we're holding down WASD, and this part is if you're not. So the easiest way that I thought to do this was just make an if statement. So we'll just go back up to above this block and we're going to use an if statement, and it's going to be input.getKey instead of getKeyDown, and it's going to be keycode.w, and we're going to use the double pipes to mean or, and then we can copy and paste it a few times. And then we can go back and change this to make sure it says WAS or D, and then we can get rid of the last or, and then lastly we'll throw this bit of code inside the if block. So now we can say else if none of those keys are held, we want to do our lerp. And since the code above doesn't get a chance to update the input using the axes, we'll have whatever the last input was to lerp to 0. So after that we can clean the script up a little bit. But now we have to do something about this head bob. Let's go down here and look at the way it works. So it uses the velocity of the character controller. But now we have the situation where, like at the very end of your walk, the camera will still be bobbing. So let's just go ahead and get rid of this function completely, and instead we'll check here when we're holding the keys down. And if we're doing that, we must be walking. So we'll put a is walking equals true. And if we're not, well, we're not walking. And then we'll put a is walking equals false. Now we can go back up to the update and we can delete the old function. And let's save and go into Unity. If we go to our player and we look at the player speed, it's different than what we set in the script. We're going to go to reset, and that's going to change everything. It's also going to make us lose our camera enum reference, so let's just go ahead and drag that back in. And if we save and test, you'll see that our player has momentum. To work on the gun, we'll need an enemy to test. So let's create a 3D capsule. We're going to name it enemy. We're going to reset its transform and pull it out of the ground. So we're going to hop into our materials and duplicate our player material. We're going to rename it to enemy. We're going to make it a red. Then we can drag that onto our enemy. Since we're going to need our gun to detect the enemy, then they're going to need a rigid body. So we're going to add a rigid body to this. Since it's only for collision detection though, we can remove gravity from it. as well as making it kinematic. So let's post this little enemy up here and we'll take a look at how the gun works. So you can see here we're using this big box collider about 1 meter wide cast out in front of the player, and it's keeping track of what enemies are in that collider. Then when you pull the trigger, it'll shoot a ray cast at every enemy that's in the collider and make sure you got line of sight to that enemy, and if you do, it damages that enemy. So with that crash course, let's get started on the gun. First we'll create it as an empty object of the player. We'll name it gun, as we also check that its position is zeroed out. So now on the gun object we need to add a box collider that we'll set as trigger. Now using scripting, we're going to modify its size and center points to represent the gun's range. So we'll go to the bottom and we'll add a component and we'll call this gun, and we'll hit enter twice and open it up. First we need a reference to that box collider that we just set up. And since it's on this game object, we can make a private reference to a box collider. And we'll call this gun trigger. And then in our start function we'll just say gun trigger equals get component box collider. Now back up top we'll need two variables to modify this box collider, and they'll both be public floats. One will be called range and the other will be called vertical range. So back in the start, right after we get the gun trigger, we'll change its size with gun trigger dot size equals a new vector 3. And for the X I want to keep 1 meter to mimic aim assist, and I want vertical range for its Y. And for the Z, it's just going to be range. So on the next line, to compensate for the size, we're going to say gun trigger dot center equals new vector 3, 0 on the X, 0 on the Y, and on the Z we want it to be half of our range, so we're going to say range times 0.5. Let's say we put this code in the update block just to see what happens. So if we save and go in here, now we can see that if we move our range, the pivot corresponds with that. So let's put this back into our start because we only want it to happen when the game starts. And up here we're going to go ahead and set our range to 20, and our vertical range we're going to set it to 20 as well. And underneath our void update we're going to need two Unity functions. One's on trigger enter and the other is going to be on trigger exit. And for our on trigger enter, we're going to want to add a potential enemy, and then on our on trigger exit we want to remove enemy. But to add and remove these enemies we're going to need to know what an enemy is. So we're going to go back into Unity, and on our enemy we're going to add a new component, and it's going to be called enemy. We'll hit enter twice, and that's pretty much it for now. And let's put these scripts in the folder. So now we can go back to our player and our gun, and inside the gun script we now have a way to get our enemies. So in the trigger enter we're going to try to get the enemy component from another object by saying enemy named enemy equals other.transform.getComponent type enemy, and then we can use if enemy, which just checks whether the enemy variable isn't null, and if there's an enemy then we can add it here. And then we can copy this over to the exit trigger because we're going to do the same thing, but only this time we're going to remove enemies. So now we need something to keep track of these enemies. Back in Unity we're going to go to the hierarchy and we're going to create a new empty game object. We're going to reset its transform to be 000 and we're going to name it. We're going to call it enemy manager. And we're also going to add a script to it called enemy manager. So double click it to open it up, and we can get rid of all the starting functions. We'll be using a public list, and this is a list of type enemy, and we'll call the list enemies in trigger, and is equal to a new list of type enemy. We're using a list because it's easy to add and remove objects to, and that's what we're going to do here. We're going to add a new public void add enemy, and we're going to pass in an enemy, and it's just going to be called enemy. And then inside we're going to say enemies in trigger dot add, and then we're going to add the enemy. And then we can copy and paste this function down below, and this is going to be identical, except it's going to be called remove enemy, and it's going to access the dot remove function of enemies in trigger. Now we can save, and we're pretty much done with this script. So let's go back into our gun script of the player. So now we know what enemies are, and we have a way to add and remove them from a collection. So first thing we'll do is declare a public variable that's going to be the reference to our enemy manager, and we'll call it enemy manager as well. So if you save and go into Unity, we have a new field called enemy manager. So let's just drag in our enemy manager and go back in the script. So down here in the on trigger enter, after we check if there's an enemy, we're going to say enemy manager dot add enemy, and then we're going to pass in enemy, and that's this guy right here. So we can just copy this line, and we're going to paste it down here on the on trigger exit, and this time it's going to be remove enemy. Now we can save and go into Unity, and we'll create a few more enemies here to test this. So now if you test out the enemy manager while playing, you'll see that our enemies are getting added and removed from our collection. So once more back in our gun script, and now that we have a way of knowing what enemies are in front of the player, let's get a way to damage them. So first we'll make our gun fire. We'll use a public float, which will be our fire rate, and then we'll use a private float called next time to fire to keep track of it. To get our gun to shoot, it's simply an if statement saying if input.get mouse button down, and we'll use the index of 0, which is the left mouse button, then we'll fire. So we'll go beneath this and we'll make the fire method, and inside of it, well, what do we want to do is we want to hurt the enemy. So once we get the enemy damage code in here, this should be fine, except for you can spam the mouse button and it's going to fire as fast as you click the button. So let's go ahead and implement our fire rate. So in this if statement, we'll say if our mouse button is pressed and time.time, which is the time this passes the game started, is greater than next time to fire, which starts out at 0's default, then fire. So right off the bat we'll be able to fire. So in our fire method we need to reset this time. So now we're going to say next time to fire equals time.time, and then we're going to add on to that our fire rate. So every time we fire, it's taking the time and adding on. So when making this, I didn't have a default fire rate in mind, so I didn't set one in the script. So we're going to save and hop into Unity real quick. We'll go to the gun, and we'll make sure that we have something assigned here for the fire rate. I'm just going to use 1 for now. And then our gun script in the fire method, we're going to finally damage our enemies by using a for each statement. And it looks like this. So we have for each variable in a collection, and we just so happen to have a collection. So the variable name is enemy, and we're going through the collection of enemy manager dot enemies in trigger, and then for each enemy that's in the trigger, it's going to damage that enemy. So we're going to save this, and we're going to make one last detour back to the empty enemy script that we made earlier. So up here we're going to need a private float, and this is going to be some health that we can take away from our enemy. And we're just going to default that to 2. Then beneath the update function, we're going to make a public void take damage. And it's going to take in a float called damage. And then we can set enemy health minus equals the damage. And then in our update we'll have a death check. And this will just be an if statement that says enemy health is less than equal to 0, then you're dead. So first we want to destroy the game object, but we also want to remove this from the list, because if we don't, we'll get some weird errors with the box collider. So we're going to make a public enemy manager called enemy manager. And then back in the update we can just say enemy manager dot remove enemy, and then the enemy is going to be this. So the enemy is removing itself. So now this one's pretty much done, so we can save it, go back into Unity. So now my enemy component has a new field for enemy manager. So I'm going to select all the enemies that I have, and I'm going to drag in my enemy manager. So now the enemy manager's done, and the enemy script is done for now. So let's go back into our gun script and finish it up. So under here where it says for each, so for each enemy that we get in our collider, we want to damage the enemy. So now that there's a function on the enemy component, we can just call it. So we'll just say enemy dot take damage, and we're going to pass in damage, which is a variable our gun doesn't have yet. So we'll go to the top and we'll make a public float called damage, and we're going to default that to 2 and give it full damage. So now we can save and test. Bang. Bang. So you can see that it works, but it works through walls too. The final thing we'll be doing is a raycast to see if the enemy is in line of sight of the player. So in the gun script and inside our for each statement, we'll start constructing this raycast. We'll start by needing a hit variable, and this is going to be a raycast hit that we just name hit. Then we can say if physics.raycast, and our origin is just going to be us, so it's going to be transform.position. And then we need a direction, and getting our direction is pretty simple since we have the enemy's transform position. So we'll say var dir for direction equals enemy.transform.position, and we'll subtract our position by using transform.position, and that should give us our direction. So now we can say that we want it to out our hit variable, and for the distance we want it to be the range of the gun. But if we test this and think about it for a second, the raycast would reach straight ahead all the way to the end of the collider, but if the enemy was say in this corner, it would not reach because the ray would have to be longer. So let's extend the range of the raycast just a little bit by multiplying it by something like 1.5. And then finally we'll need a layer mask, and this is just going to be called raycast layer mask. And we'll go up to the top and make a reference to this by saying public layer mask, and it's going to be called raycast layer mask. So back inside the if statement of our raycast, so if we hit something, now we're going to do another comparison. We're going to say if hit.transform is equal to our enemy.transform. So this goes through our list of enemies, gets the direction towards the enemy, raycast towards it, and after all that, if it hits the enemy, we can finally call our enemy damage function. And now we can save this so we can go into Unity. And now we can set up our layer mask. This box collider here is the reason we need the mask. We need the raycast to ignore this collider. So we'll go to our layer, add new layer, and we'll create one called gun. And then we'll have to go back to the gun object to assign its layer as the new gun layer. Then we need to go to the gun script component in the inspector, and for the layer mask, we'll select default. And this will correctly ignore our gun layer. This would be easier to visualize by adding debug.drawRay in the code, and we can use our origin and the direction that we've already calculated. And since it happens in a fraction of a second, we can also use debug.break to pause our editor so we can see what's happening. So I'm going to shoot this guy here, and it paused and shows us the line, so we continue. So now this enemy over here by the wall, so they're in the trigger and I'm spamming the button, but nothing's happening. And it's not until I walk around the corner and get line of sight that now the game will pause and let me know that I've hit this enemy. Now that we know that works, we can delete those debug lines, and I think to pretty much wrap up this system, we can do a range check, so enemies farther away can take less damage. To do that, we'll use a float for our distance, and we can set that equal to vector3.distance. And we want the distance from the enemy transform to our transform. Then we can use that float in an if statement saying if our distance is greater than our range times 0.5. So I'm saying if our distance is greater than half of our range, then we're going to damage the enemy some. Else, if the enemy's in the first half of our box collider, that means it's closer and we're going to deal a lot of damage. So we're going to grab this enemy.takeDamage function and we're going to paste it in both conditions. And in the true condition, we'll set this to small damage. And for the false statement, we'll go with big damage. And back up at the top, we'll change our regular damage to big damage since it's already set at 2 and our enemy only has 2 health. And then we'll make a new float for small damage and we'll default that to 1. So I'll look over the script one last time, and then up here we're gonna add a comment for this line, and now we can save and go back into Unity. So let's check over the gun script and make sure all the variables are assigned, and make sure that all of your enemies have the enemy manager assigned. So now if we test, we should have our enemy detection system fully working. We have a gun, we have enemies, we can shoot them on level ground and elevated or lowered positions as long as we can see them, and they can take damage with 2 different versions of damage. From here we have a good base for everything else. So until next time, SpawnCamp out.